Let us say that we have a unit circle centered at the origin O on the xy plane. Let us label our points, and 1, 0 equal point A. Let us have a point B on the intersection of the unit circle that forms some angle AOB. Here is the line segment OB. Then, we can have a segment splitting the region between A and B on the circle, forming two different angles. We can call them alpha and beta, as shown. This will make angle AOB equal alpha plus beta. How do we find the length of AB? We can use the distance formula using coordinate geometry. First, we must find the coordinates of point B. This is a unit circle, meaning that the x-coordinate will equal the cosine of the terminal angle, and the y-coordinate is the sine of the terminal angle. The terminal angle for this point is alpha plus beta. Now that we have coordinates for points A and B, we can find the distance using the distance formula. The distance formula is d squared equals x2 minus x1 squared minus y2 minus y1 squared. Using this, we can write the following equation. Now we must expand these terms as follows. Using the Pythagorean identity, we can say that sine squared of alpha plus beta plus cosine squared of alpha plus beta equals 1. This will cancel out the like terms. Now, let us have another circle on the xy plane. Keep the same points, but rotate the points A and B about the origin by negative alpha. How will we do that? We are keeping the same angles, but we are just moving the points clockwise about the origin. Let us let this angle have a measure of alpha, and this angle be beta. Let us have the new point A rotated to be point C, and the new point B to become point D. We can obtain the coordinates of these points as shown. Because point C is below the y-axis, it must have a negative y-coordinate. We now do the same thing as before. Find the length of CD. We use the same distance formula as before, now that we have two new points. We We can now expand these two polynomials, just as before. Because sine squared plus cosine squared equals 1, we can cancel out both of these for alpha and beta. This makes our calculations easier. After simplification and reducing like terms, we will get this equation for the length of CD. Here is our value for AB squared, and here is our value for CD squared. Since the points C and D are obtained by rotating 2 points, the angles between them stay the same, meaning that the lengths of CD and AB are the exact same. We can therefore set them equal to each other and simplify the expression. Therefore, we get that cosine of alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. This is how we derive the equation for the sum of two angles.